All right, let's talk about odd and even functions. We're going to do that graphically and algebraically. Graphically, it's pretty, easy to see once you kind of look at the graph and see what behavior it should have. So even functions are symmetrical across the y. So if you fold this paper in this half, this part of this function is going to overlap with that other side, so the left-hand side. If it's odd, it's symmetrical about the origin. So the best way to look at this is if we plug in this number here, so whatever this x value is, you get this output. Well, if you plug in the negative of that value, you're going to get the negative of that output. And so you could do this for this entire function. And that's sort of a reflection across the origin. But doing a reflection across the origin is going to be harder, right? So just think about that feature. You plug in this value, you get this positive output, and then you plug in the same negative value, and you get the negative output of the same number. Okay? All right. So algebraically, this is the one that's a little bit more difficult to figure out, in the beginning, but after you do a few examples, you'll get it. So the best way to do this is always try to prove to see if this function is even. Okay? If it's not, then you're going to try to prove that it's odd. And if it's not odd, then it's neither, right? It's neither even nor odd. So here we go. So both of these, whoa. So both of these you prove the same way. You plug in a negative into your function. See, on this side too, a negative into your function. But if the negative does not affect your function, meaning your function still looks like the original, then your function is even. If you had to pull out a negative or factor out a negative, and then you see your function, the original, then it's odd. So I've done this before, so I'm going to show you even, then odd, and then neither. So let's actually work in that order. So instead of doing number one, we're going to do number two because that one's going to be even. So if we plug in a negative into that function, so it'd be negative x squared. So this is what I mean. You're plugging in a negative. Okay, then add the 10 from the original function. So, immediately you should see that this is this function, except we plugged in a negative x into here, okay? So then you just do the math. So if we do the math, this negative outside is still negative, and then any number squared like this is going to be positive, so you're left with x squared, and then plus 10, nothing happened to that. So then you ask yourself, does this, whatever I did here, does it look like my original? And if you said yes, or if you say yes, then that means the negative did nothing to your function, right? So this looks exactly like this still. So therefore, this is set to be even, right? Because even a negative value that you put in did not affect it. So this function is even, okay? What that really means is that function is symmetrical like you see up here, the one down there, except it's shifted up 10 units only. And it's flipped down, but it's still symmetrical. So just to give you an idea, this is this function, okay? So visually, it'll still make sense that it's even because it's symmetrical across the y-axis. Okay, so let's do one that's going to be odd. So let's just do number 3. So number 3, same thing, right? Same approach. So you input a negative, and then you do that to all the x's that are in your function, okay? So we just do the math. So anytime you have an x value raised to the odd power, your output is still going to be negative. If it's even, so 2, 4, 6, 8, it'll always cancel out the negative, therefore it'll be positive. But because this is odd, it's going to be negative still, okay? Plus, and then, well, this is where you got to be careful. You go back to algebra, right? Negative times positive is negative, so negative 4x. Now you ask yourself for a second, now that we did the math here, does this look like number 3? That's what we did, right? And your answer to that should be no, at least not right now, okay? So because it doesn't look like it, it's not even, right? We didn't do any math. So, I mean, we're not doing any math right now after we finish it. But because it doesn't look like number 3, it's not even. So in order for us to make it look, or to see if it's odd, we need to factor out a negative. Always, right? So, okay, we decided it's not even, so we have to factor out a negative. And then anytime you factor out a negative, just follow immediately with an open parentheses, and then you go back to your basics. Negative times what gives me negative x cubed. You're missing the x cubed. And then negative times what will give me the negative 4x. So this has to be positive 4x. So when you distribute the negative, it's negative 4x. Now, so this is where you got to pay close attention. Is this f of x? Okay, because if it is, you now have the negative, right, that this has to be. And if you have the f of x, then this is going to be an odd function. So does this match the original? And the answer to that should be yes. So see, x cubed plus 4x. So now that you have the negative of f of x, this satisfies this condition. So that means it's odd. So there. And that's the same approach you do to any of these types of problems if you're trying to figure out if a function is odd or even. And now I'm going to show you one that is neither odd or even so that you could see that you still have to go through this process. So that's going to be number 1. So I'm going to go up here and just do number 1. So that's going to be f of, again, always plug in a negative. That's negative x cubed minus negative x squared plus 4 times negative x plus 2. I'm running out of space there. And then just work it. So here we go. We have a odd power, so that's going to remain negative. We have an even power, so that's going to become positive. So let's just stop there. So that's x cubed, but because it's odd, it stays negative. The second one, you have to be careful, right? This is positive because it's even, but you still have this negative, right? So it's going to be negative x squared. And then careful here as well. That's a negative times a positive. Okay, so that's negative. So negative 4x and then plus 2. We don't do anything with that 2, but bring it down. So now we ask ourselves, after we finish that little bit of math, does this look like the original? So when we go here and then we ask ourselves, does that look like that? Hell to the no, right? Because we're missing the negative. Well, first of all, this negative is not in the front over here. And then this minus 4x is not minus 4x up here. So you're done with that. It's not even. Therefore, you now have to factor out a negative to see if it's going to be odd. So there's your negative right there. And then you open up a parentheses. And just to, again, this is just algebra. So I'm going to speed through this here. Okay. So that should be that right there. Negative times positive is going to give me a negative. And negative times negative will give me a positive. So if I distribute this negative in here, right, into all these terms, I should get what I had up here. And just let me quick verify. And yeah, we're on this. Yeah, we're good. Okay, so now, one more time. Does this look like f of x? Because if it does, then we have negative f of x. So I go back to draw an arrow here and I look at this and no, it's not f of x, because just because of even just this right here, that's a minus, that's a positive. So that doesn't match. So this is not even. So this made it not be even because it didn't match. Now this does not match f of x, so we don't have a negative of f of x. That doesn't match. So we don't have even nor odd. Therefore, it's neither. This function is neither even nor odd. That means that there's basically nothing special. There's no patterns. There's none of this happening with that graph. There's none of that. There's just some random graph you can't really do anything with for our purpose. So that's it. This is the video of how to find or figure out whether a function is even or odd.